So, hi everyone. I hope so that I'm audible and visible to each and every one of you. Right. So, welcome back to the session. And today, I welcome you all once again to a journey with Scikit-Learn. And in the previous session, if you have attended, in the last class, we were basically talking about that what we can actually do with Scikit-Learn and exactly what Scikit-Learn is for. What was exactly machine learning? Why is it important nowadays? Why do we need to actually assess what type of models do we need to use? What are the challenges associated with these type of models, and so on. So today what I want to be doing is that today I want to expand this further, and I'll be talking about a little bit more things and a little bit more detail, and what our goal or agenda for today is going to be, that we have to build our data in such a way that it is able to be used in any machine learning model. What are the challenges with it, and so on. So I'll just quickly present my screen as well, right? And what I'll do is I'll come to this particular part where I have to actually talk about that what kind of art is there for data pre-processing and why is it actually that particularly so important. Now, as I told you in the last class, that the thing is that whenever we have actually a situation that we are using data to train our model, the thing is that the data is a key factor in determining that how good your model is going to be. That means if your data is not right, then your model is supposedly going to be a waste because it won't be used in that particular sense in a very good manner. So what we have is that whenever we have certain scenarios like this, when you are actually going to be importing your models, using your models perfectly, and now you have the perfect pipeline with you. But whenever your data is going to be dirty, you will notice that whenever you go for running and fitting that particular model, you will encounter a value error. That means it could not convert certain data types into something. Maybe it was having some issues with it, so there were a lot of assumptions and a lot of things that could be done. So what I'll do is I'll just try to simplify this process. And for that particular reason, what I'll do is I'll just simply come to a Google Colab, and I'll just open this Google Colab environment and open a new notebook like this. Okay. And in this new notebook, I need to be talking about some data pre-processing. So let's just wait for this to open. And once this is open, let's just say I just rename this part as cleaning data. Right, I'm just going to be telling this that the notebook which I'm creating is the cleaning data. Okay, now just for the simplicity purpose, I'm going to be copy pasting some predefined data frame which I'm going to be using. So but again, before working with that, I need to specify that I'm going to be working with Pandas. So I'll just import Pandas as PD because that is the library that we use for working with data frames. And data frames is something that Scikit-Learn is quite useful for, right? Because it understands what Pandas is, it understands what these type of data structures is, and that is it is able to pre-process it a very lot better. Okay, coming back to that, I'll just import Pandas, right? Once I'll do what is that, after that, I'm just going to be copy pasting this particular data set, okay, so that I'm able to showcase this particular process. Once this is done, I'll be try to I'll also need to import my import numpy as np. Okay, no problem. Once I do this, I'll just try to show you this using df.head. I hope that you can observe that in this particular scenario, we have a column called age, right? We have a column called age, and with that age, I have a column called salary. So whenever I talk about this column age, you will be able to see that I have like all the values with me, such as 25, 27, 29, 31, 33. Perfect. But if you look closely to this particular column called salary, you will be able to see that after a value like 50,000, 55,000, I have a value called NAN. Now, just think about it. If you were to build a prediction model, or even if I was to ask you some kind of prediction, any kind of prediction, if I don't give you the data for you to make prediction, I don't think so that you will be also able to make some predictions or give at least a probability or so. So for that particular reason, I hope so you get the fact that if I just pass this type of data into my model will of course fail to predict anything because it doesn't have the complete data. So we of course need to handle this particular situation. Now there are 2-3 ways in which you can basically do it. The first, foremost, and the best particular way, which people call it the best particular way, is because why not just simply delete the missing values, right? Why not just delete the missing values? This could be like, I'm just going to label this as, let's just say, approach 1, right? Why not just delete the process, like just delete everything that I have? So what I'll do is, why not go for df.drop, and after that, since I want to remove not available values, I'll say drop na, and why not just run this? So you will see that in this particular scenario, the row 2 which I had, which was containing the nan value, is now missing, or at least is something which I have deleted. But despite this being the most simplest and the most less effortful process, I hope so you get the fact that if our data had a lot of these kind of values, we won't be able to preserve our data that much. And it's not a good situation to run into. Let's just say you had 100 values, out of which, let's just say 20 or maybe 25, or let's just say NA values, and you just drop them. So by statistics, simple maths, you will be able to see that you have dropped 25% of your data that could have been valuable for you. So I guess we cannot follow this approach unless there's nothing else we can do for it. Now, of course, the second approach comes to the fact that why not fill the data, right? This is something which I'm calling as approach 2. Like, why not go for filling the data? Like, just fill the data. But again, the question comes to the fact that how do I know that particular value, or how do you think so that I should be able to fill it? Like, if I was not aware at the first place itself what the value could be, then how can I actually fill that particular part? So there are two ways in which we can fill this data, and this is where something strikes in your mind that how can I do it, and then this is something which will get interesting. Now just consider this particular column, salary, right? Now just think about it. If, let's just say, I don't know this value, and if I were to assume this value, any case of scenario, like let's just say if I wanted to assume this value, can I say that I could have used, let's just say, their average or mean value? Maybe I could have used the mode value, which is the most repeating value, or maybe the middle value, which is median. Like any kind of value I could have used. This is like a statistical value which I'm going to be putting inside this particular data, right? So for that particular reason, we have a library which is basically called, like, in this something which is present in Scikit-Learn only. So I'll just say that from Scikit-Learn dot, I'll say impute. I'm going to be importing, like I'll just import a SimpleImputer. Okay. Now what this is going to do, this is pretty much very, very simple. What you need to do is, I'm just going to be creating a variable. For example, I'm just saying imputer1. I'll just choose imputer1. This is like the variable which I have created, and after the creation of this variable, I'm going to be using this SimpleImputer. And inside, if I hover over this particular thing also, you will be able to see that it basically is going to be requiring a strategy. Like, you can even read out this particular description. It says that univariate imputer for computing missing values with simple strategies. Like, this is the simple and foremost definition of it. And you can see that it is going to be replacing missing values using descriptive statistics like mean, median, or most frequent. Or you can call this most frequent as mode. That is the option we have. Now, inside this, all I need to do is, like, let's just understand how this works. Then I'll tell you how do you choose that particular fact. I can just simply say that strategy equals to, and inside this strategy, inside double quotes, I just need to specify such as mean, or maybe median, right? Or maybe I can even go for most frequent, just like this. This is like how you basically do it. And once you are done with this, what you basically, after this particular thing, is just go and on your, let's just say, df2, which I'm going to be creating afterwards, this particular thing, I'm just going to be saying that in this, do what? Using this imputer which I have created, like using this imputer1 which I have created, just fit and transform that particular part, and just pass in on which particular column you want to do this. So this is how easy it is. That is how you can basically do it, right? So now the question arises that which particular strategy should I be choosing? Now for that particular reason, we must understand the data I have. Okay. So if I try to show you this particular thing using this particular graph, you will be able to see that if my data is following a normal distribution just like this, like let's just ignore this particular part. If my data in the center is making this high peak and then afterwards it is going to be coming to a decline, in that particular situation, whether I choose mean, whether I choose median, whether I choose mode, or you can say the most frequent one, is going to be the same, because all of these three values are going to be the same. This is known as Scikit-Learn limit theorem, right? But if that is not the case, like if I have my data which is not following this particular situation, I usually tend to avoid this type of simple imputers. Okay. So in our particular situation, you can see that there is not a very vast distribution of these kind of values. So I can either choose median or mode, that's up to me. So for now, I am just going to be saying that why not use the strategy as mean? Like I'll just simply choose the strategy as mean. And after that, I'm going to be just running this particular imputer. Now, since I have to repeat this process over and over, I'll just say that I'm going to be creating df2, which is going to be like df's copy. So I'm just going to be saying that df2 is equals to df.copy. And since I'm going to be, like afterwards using the same df, so it's safe for me to make a copy. Now, I'll say that df2 inside, because I'm working with the column called salary, I'll just copy this particular part. You can even examine this particular thing. Like even if right now I like run this part, you will see that it has this particular NaN value, right? So after that, what I'll say is that since I want the values on this particular column to be changed as per this imputer, I'll say that just go for this imputer, which you have created like imputer1, and I'm going to be using a function called fit and transform, just like this. Okay. And inside, just passing on which particular column you're supposed to do so. So here, I can just simply copy this particular part over here. And once I do this, right, once I do this, just a second, guys, I need to check this particular part, right? I think I'm missing columns, right? Okay, sorry. Once I do this, you will be able to see that now that I am done with this, I'll just simply call this df2, and inside you will be able to see that now I have the value 60,000. That is how this particular mean strategy works. If you change this to, let's just say median, for example, like inside this particular pipeline, I'm not going to be changing anything. If I just simply choose median, do this same process, run everything, then you will be able to see that I'm able to still get a median value just like this. Okay, so that's up to you, because our data is going to be inside this normal form. So that's why we don't have this particular situation to worry about. Next, the other option is that I can choose data like data. And what do I mean by data like data? That let's just say that since I want to fill this value, right? So why not fill it with the closest resembling value? Okay. And what do I mean by this closest resembling value? If I try to show you this particular thing using an example, what I'll do is, like, if I want to showcase you this particular thing, like if I just copy this part here, for example, this is like something you must have seen in your life. I hope so that everyone seeing this right now must agree with me that this is basically a dog, right? And let's just say this is also, I guess, a dog, right? And again, this particular thing is also a dog. Now let's just say that you are missing a picture, right? You are missing a picture in your gallery, which was supposed to be, there, but it is not there. So what should be the guess that you should be making that would be of that particular missing image? If you guessed that that particular image is going to be of a dog, that is what I call as closest resembling value. So for that particular scenario, we have a library, or you can say a thing called KNNImputer. And what that KNNImputer simply implies is what? I'm going to be choosing the closest particular value that can be there or resembles the most to that missing value. Okay. So again, it's simply very same. What I need to do is from sklearn only, from sklearn dot imputer, I'm going to be importing what? KNN, right? And after that, I'm going to be importing this particular imputer, just like this. sklearn.imputer, imputes needs to be there, and this is how you basically import this KNNImputer. right? So again, just the same scenario I had, I'm going to be simply creating one more imputer variable just like this, which is going to be imputer2. And now in this scenario, I'm going to be saying that I need to have this particular imputer. And now if I just hover over this fact, you will see that what it is going to be doing. If I hover over this, can you see that it is going to be imputing for the completing missing values using the k nearest neighbor. Now, what do I mean by this? This k is going to be determining that how many close points do you need to determine this closest value. For example, like if I try to show you one more image, like if I try to show you this particular image, let's just assume that this particular thing which I'm trying to guess, like this ball, let's just assume that this is not blue and this is some X color or Y color, I don't know what it is, right? And if you were to guess this particular ball, can I say that it is right now closer to blue ones? है and it is also close to red one also, but compared to that, can I say that it is going to be closer to these blue ones which I have here? And despite this blue ball going to be a blue, you can see this is a little bit further compared to these blue balls. So what I need to specify in that, I need to specify the value of this particular thing called n underscore neighbor. That means how many values do you want in determining that what is going to be the closest possible values. Okay. So there are other factors also, like you can simplify this particular part as what kind of weights do you want, what metric do you want to do it for, which we can discuss in a little bit later format. So in this case, I'll just simply say that why not fill them using the nearest neighbors as the value such as 2, right? Why not do it as per this particular case? Very simple. Then I'm again going to be creating a simple copy of this particular data frame just like this. And after this is done, I'll simply go for df3. Again, the salary column is going to have some missing values. This one, you can see that this is missing, which was originally also missing. Again, I'll just do the same particular thing, that using this imputer2, I'm going to be using the fit transform function, and inside just pass in this particular thing as a column, just like this. Have this particular thing over here and also this particular thing over here, right? Once I do this, and if I try to show you df3, you will be able to see that it is also able to get this particular value just the same, because the data is very small. You can't see that big of a difference, and we have this particular thing as well with us. Okay, so this is how you basically use, like the imputers. Like, of course, the approach one can't be used a lot very often unless we don't have any other option to fill it with. Next, we have the approach of filling our data. For that, I told you this is like imputer, which you can use. So this is like your first imputer, and this is KNN is like secondly your second imputer. Now again, if I had to choose between both of them, I can't simply say that this is going to be a lot better than this one or vice versa. It really depends upon what type of data do you have. If you have a data which has like spikes or anything like that, which is going to be having, like a little bit of skewness or anything like that, for that particular reason, I can just simply choose KNN to prevent any kind of biasness. And if I wanted my data, if my data was like this, which is going to be following a bell curve, I can just simply choose a imputer using a simple imputation, and I can just simply put it with mean, median, or mode, whatever I like. Okay. So I hope so that this was fine explaining. Like, I think so this was done. Right. Perfect. So moving on, what we can now do is, let's just talk about this particular thing that is known as inconsistencies in our data. Right. What are these inconsistencies? Now the fact is that, of course, there can be a situation that you have many missing values, like 20% missing values can be there, and like just as I told you, but there can also be inconsistent labelings. For example, what I mean by that is, like, let's just understand. For example, if I wanted to say, like, let's just say I am working, like, if I write red like this is also fine, right? If I should use a text cell for this, why not go for a text cell? Right. Yeah, this would be better. I can like red like this also, right? I can write red like this also, and I can like write red in this format also, maybe in this also. Now, the fact is that since all the words which I'm trying to show here actually refer to the same thing, they actually refer to the word, or you can say the color, red. But can you see that there is an inconsistency in the way I'm representing this particular thing? That means, can you see that if I were to choose only one particular format, such as if I choose this one because this is like by convention the most used one, or maybe like all in lowercase, but any kind of scenario if I have, let's just say which is going to be like this, or even if I have like everything small and the last word is capital, that can induce inconsistency. And I need to fix this kind of inconsistency because I know that this is red as a human, but the computer might think that they all are different words as per the ASCII code. If you don't know what ASCII code is, I recommend that you go and type in the ASCII code, and you will be able to see that what this particular ASCII code means. Like any given alphabet that you have is going to be having some kind of value associated. So you can see that like, yeah, you can see in this particular thing, just a second. Yes, that your capital H has like 72 as the value. Your special characters also have values. Your lowercase values also have these values. So your computer is going to be recognizing these words using this particular ASCII code. So to prevent that particular part, what we do is we try to standardize this part of the situation. And how do you standardize? I'll just simply try to make you understand how do you standardize this part. Let's just say that if I just copy one more data set with me, right? Like if I just create a data set, right? Since I have imported pandas, I'm going to be saying that why not have an inconsistent data? Okay, pd dot data frame. Okay. Inside, let's just copy all of these values. Like in the format of a list, I'm going to be saying that why not have red, also have red, also have red, and also have like red as this, or anything else you want. You can just simply do this. Once you will be able to do it, I'll see that once now I copy this particular print and try to print it, now you have these kind of inconsistencies with you. If I wanted to name my column, I can even go for columns, and I can just simply say why not have this as color, right? And if I run this, you will be able to see that now I have this particular column named as color. Now to fix these kind of inconsistencies, what I can do is, why not simply like try to replace this or try to find a pattern here. If I want to show you guys, like just think about it. What kind of pattern do you see? Any pattern, if you guys can see? Any pattern? Can I say that all of these colors which I'm actually using, or any colors which I have listed, actually refer to the same thing? Yes or no? Like they do refer to the same thing. So what I can do is, I can just simply set a thing such as for this particular column color, like I just say for this particular column color, I need to do what? I need to replace, let's just say, first of all, this capital color, take a capital in this particular way, which I have written capital. And after that, I'm just going to be replacing them as, let's just say I'm going to be using this particular part, right? Once I run this, if I again try to showcase you this, can you see that now anywhere which that particular orientation was used, which was all capital, is now converted to this particular thing only. Perfect. Now, if I wanted to do this in one step only, what you can do is you can just simply pass this particular thing in the way of a list. That means if I come here and type in all the variations of red which I have in this thing, like in this particular format like this, you will be able to see that now I am able to convert everything into a standardized form like this particular thing. This is your standardization in terms of text, that everything is in a consistent manner now. So you can have all of these inconsistencies written with you and replace all of those inconsistencies in one single line of code into a standardized word or anything which you are trying to do it with. Okay. Now comes the best part, which I really like. It is that now I have to talk about scaling and the squish effect of scaling. Like, what do you actually understand by this scaling part? Now, if I wanted to make you understand this particular thing, just think about it. Let's just say that if you have 2000 liters of milk, like I just represent this like this, and I'm saying that you have this many milk, you have this much, let's just say water, you have this much as your sugar, like just use the units as you want to, and let's just say that you have this much as your tea bags. Giving that everything like that is there, like the whatever thing you do, like maybe I use induction, so you have inductions and everything with you. But what I'm saying is that you only have like 4 cups, right? This is the situation that you have. Like, given that these are your ingredients, like these many things are like, let's just put the units as well. It might look a little bit cooler, right? I'll just simply write it like this. Maybe this is also grams or whatever it is, or maybe units or whatever it is. Take it. Now just think about it. If I ask you guys, how many cups of tea can you make from this? How many cups of tea can you make? I hope so. The logical answer to this is that you will be able to make only 4 cups of tea at a time, at least, because the only limiting factor that you have is this particular 4 cups that you have. Otherwise, from this, I guess you can make tea for the entire life of yours, maybe. Or maybe if you drink a lot more, I don't understand, but that's what I'm assuming, right? But the thing is that since this is your limiting factor, or maybe because this unit is a little bit much smaller, you are bound to think that you will be able to make only 4 cups of tea. But what if I tell you that each of this cup is basically of 100 liters? Then your answer might change. Like, again, you are able to make only 4 cups of tea, but now the amount of tea is going to be a very large amount. This is what I mean by you can say like standardization. That means if one factor is going to be a lot smaller than the other, your model is able to, like get confused. Like it will assume automatically that this particular thing has more influence on my prediction than a smaller unit like this. So to solve this kind of problem, what we do is we try to standardize our data. Okay. Now the standardization process also has like a lot of, like you can say, a lot of variations to it, like how you can basically do it. So let's just look into that. And one more thing, that you standardize your data for distance-based algorithms. Like whenever you're any kind of algorithms you have, and they are going to be distance-based, which we will be talking about once we talk about models, but you get a little bit idea that whenever my factors are going to be used in an algorithm that is going to be calculating distance, or in other words, you can say that if it is going to be a distance-based algorithm, there we have to always and always standardize our data. Okay. Now for standardization part, what I'll do is I'll use again the Scikit-Learn library. I'll just simply say that from Scikit-Learn dot preprocessing, I'm going to be importing what? I'm going to be importing a StandardScaler. Check it. This is like a StandardScaler I have. I'll just tell you in a while what it does, but I need to create one more code cell for this and move this up a little bit like this. Right, perfect. Okay, this is a keynote, like please remember this, guys. Maybe in the future also it might be helpful to you. Now I'll just simply copy paste the data once again, because that will save time as well. Okay, this is like a data frame which I have created. Why not say that df maybe scale? That's what it was written, but okay. Now if you look at this particular thing, you can see that we have income with us. This is 40,000, this is 45,000, this is 50,000, this is 55,000. But in between all of these kind of values, can you see that now I have a value which is basically 10 lakh, or you can say 1 million, or maybe it's 10 million, right? Yeah, it's 10 million. So you can see that it is going to be having a value which is a lot more bigger compared to any of these values which you can see over here, right? So to prevent this kind of situations, what we usually do is we try to standardize this also. What I'll do is I'll come here and using the standard scaler, and again, the same process is there. What you do is you just simply create like standard scaler is this. Okay, and now I'm going to be using this particular thing which I just imported, and I'm just going to be giving you a heads up. This converts it into a factor in which you have the mean as 0 and your standard deviation as well. You can look up the statistics as well. It is going to do that particular part only. So this is why we use standard scaler to convert our data into be having a mean of 0 and a standard deviation of 1. So if I were to use this particular thing, what I can do is I can just simply using that same particular process we had just used for, I'm first of all going to be creating this as a copy like df scale 1. I'm going to be saying that this is the copy of df scale part. Okay. I'm just going to simply create a copy like this. Now what I'll do is using this scale 1's column called income. I'm going to be doing what? I'm going to be saying that ss dot. If you remember, the same pattern is there. Like I'm just going to be saying fit transform, and inside I'm just going to be passing that particular column which I'm using. So I'll just come here, pass this thing in a series just like this, and once I'm done with this, if I try to like print this particular data frame here, you will be able to see that previously, if I first of all print this part here as well. Okay, if I do this here also, right now your data was like this. It had this a very high value. Now you can see that now it is converted in this particular format. That means you have your values in a much closer range compared to whatever we had previously. That means I guess 55,000 was way far away compared from like 10 million. But now you can see that 1.9 is a little bit closer to 0.4 or minus 0.4, which is not that big of a difference compared to what we had previously. Okay. Another way by which we can do is we have again from that same library, which I'll just copy paste for saving time. If I were to use this particular thing only and I go to import, I have another type of scaling which is going to be MinMaxScaler. Now, what does this MinMaxScaler refer to? This MinMaxScaler is going to be converting all our data into a minimum and a at most maximum value. Like it is going to shrink our data into that particular range. And that range usually is from 0 to 1. And if you have negative values, it ranges from -1 to 1. Like this is an arrow. From -1 to 1, that is what happens. So what I'll do is I'll just simply create a maximum scaler like MS. I'm going to be saying MinMaxScaler. And I'm saying that again, I'll just simply call it like this. Okay. And following that same process which I had, why not create like df scale 2? Like I'll just simply create a df scale 2, which is going to be a copy of this particular thing, right? And after I created this copy, I can just simply using this particular thing as df scale 2. Again, I'm going to be using the income column, and on it using this variable which I just created, I'm going to be applying a fit underscore transform, right? And I hope so that by now you must have got the pattern. I'm going to be just passing this particular thing in this format, right? And once I do this, compared to what we had previously, just remember, if I like now print this part, you will be able to see that now your minimum value, which was like this smallest value here, which was this one, is now referred to as 0. And the highest value is now converted to 1. What this does is it's again shrinking down our range. That means we do not have any problems in which we have to go outside a range, or maybe if any value is going to be having a lot bigger value compared to other ones. So that is like one way of doing it. One last way, what we usually use is sometimes is that we have from this same particular library of preprocessing, I have another type of scaler called the RobustScaler. Okay, and I'm going to be showcasing you this, and I want you to just observe what is the change between this particular thing and RobustScaler. Like if I was using a MinMaxScaler versus a RobustScaler, what difference do I observe? So again, the same process, I'll just simply create this robust scalar just like this. After that, I'm just going to be copying this particular part to create a different copy like this, right? After that, why not just simply say that in this case, I'm just representing this as 3. Here also I'm going for 3. And now after doing all of this, if I was to simply print this particular thing, you will be able to observe something. Anything if you can observe. I'm just giving you 2 minutes. Please observe this one. I need to change this also. I'm so sorry. Yeah. Now observe anything if you can see. If you can observe, you can be able to see that all of the scalars which we had used like previously, were taking into an account this particular value, which was like, oh, sorry, which was this 10 million. But the moment I use RobustScaler, what it does is it is completely ignoring this value as it. Like you can see that it is applying some scaling on the initial parts, but whenever it encounters a very large value, it is somewhat not performing anything on it. Like it is as if it just let this particular thing be. This is what we usually do when we have to like separate, like whenever we have a situation where we want to separate any abnormal values from our data, we usually tend to use a robust scaler. And what it practically does is that whenever I want my data set to be free of these values, which are basically my abnormal values, I try to use a robust scaler, that after which I can just simply create like a greater than or equals to condition, and after that I won't be able to have any of these values. These abnormal values are formally called as outliers, and based on these outliers, my model's performance is going to be very impactful. That means if I have a lot more outliers in my data, then my model is going to be performing way worse compared to if these values were not there. So whenever this kind of situation is there, when we don't want any kind of outliers to be there, and instead of manually separating them by any other method, this thing does it automatically for us. And after that, I will be able to just create a simple if else condition, and that is going to be sufficient for it. Okay. So this is, we have like the standardization, MinMaxScaler and RobustScaler for numerical type of data. Now, what about your other type of data, which is basically your text? Now, what about text? What can we do for text? I hope you understand that in the last session, I also told you for a fact that I don't think so machine learning models can work with text data. I don't think so, because they understand numbers just as in any other computer language converts your language into zeros and ones. Machine learning models also have a tendency to convert any kind of texting, or at least they want us to do it for them to be converted into numbers. Okay. Now I'll just take a very simple example. If you understand that part, I'll just try to create a simple example. That is, I hope so you realize that any color that you see on your screen is made up of red, green, and blue. Like you have these particular things with you, these colors are there, and mixing these three colors, like having some values of it, you will be able to form a color. Okay. Now forming that particular color is going to be something which can be achieved in scale. Just give me a second, guys. Just a second. Yeah, sorry for that. So what I was saying is that if you look at this particular thing, you will be able to see that any color that I have on my screen is going to be either red, either it's going to be green, or either it's going to be a blue. So any color that is going to be on a screen is going to be formulated based on some values of red, blue, and green. So if I say that, let's just for simplicity, if my color on the screen is going to be only red, then can I say that all of these values needs to be the minimum, and this is going to be the maximum color? But I hope so. I don't think so. Computer understands the word red, green, and blue. So for that particular thing, what we do is we assign some numerical values to it. Now 255 is something that we assign for red whenever we want to go for red, and rest all of these values are simply went for 0. That is what we have. So using the same concept, if let's just say I try to give you a data set which has these kind of numbers like this. If I have this particular thing with me, which is df encoded, and if I try to print this particular df encoded, you will be able to see that now I have colors just like this, and I also have size just like this. If you will observe, there is an orientation based difference in both of these columns. Can you guess that difference in both of them? I hope so. You can see that in the column size, I have a hierarchy with me. And what is that hierarchy? I think so small is greater than medium is greater than small, and large is greater than medium. That means I have the first thing to be large, then I have medium, and then I have small. That means I have a hierarchy which is getting followed. Just as I can take some other example, such as beginner, intermediate, advanced, right? Maybe old and new. In that case, we also have an hierarchy in that particular case. But in the case of colors, I hope so you can see that I don't have any hierarchy as such, which we have in the size column. That means I can't say that red is going to be greater than green, or maybe green is going to be greater than blue, or blue is going to be greater than red. That is not the situation I have here. So this matters. Like this type of data that is going to be having no hierarchy is what I call as nominal data. And whenever my data is going to be having some hierarchy, I can call it as ordinal data. Now, why is this important? Because whenever I'm going to be converting them to numbers, this thing really matters. And how is it's going to happen? Let's just say that from Scikit-Learn, I'm going to be using an encoder. I'm going to be saying that from Scikit-Learn.preprocessing, I'm going to be importing a encoder. Now for that encoder, if I had to choose like label encoder, okay, what this does is it is going to be converting this type of data into zeros and ones and twos and threes, like simple numbers. Let me just show you. Like this is the same process. Let's just say I go for label encoder as LE, and using this label encoder, I'm going to be saying this is going to be over here, right? And just after this, I'll again maybe create a copy of it as well, maybe df4 I'm going to be saying, which is a copy of this df encode, right? And I'm sorry, I need to go for copy. And after that, what I'll say is that if I take this df4, right? If I take this df4 and use this particular thing on my color column, right? If I wanted to do it on this color column, okay, if I wanted to do it on this particular column, where exactly there is no hierarchy, but still, if I wanted to do this, like if I say that why not go for le.fit and transform on this particular thing only. Okay, I'm just passing this like this. And once I'm done with this, you will be able to see that now my color column is converted such as 2, 1, and 0. That means originally, if I also go for df encode, like if I just simply write over here, maybe if I go for this particular thing, you can see that it has assigned blue as 0, green as 1, and red as 2. Now just think about it. If normally, if I was to think, even if I was not a machine, like I am not a machine, but if you think about it, can you see that I will automatically assume that since 0 is smaller than 1, then can I say that 1 is going to be greater than 0? And similarly, 2 is going to be greater than 1. Okay. But these 0, 1, and 2 are actually representing colors. Again, 0 was representing blue, 1 was representing green, and 2 was representing red. That means now, according to the situation, like according to using this label encoder, what the situation I have created is that I am making the model assume that red is going to be having a greater value than green and much greater than the value than blue. That is the situation we have. Now, since we don't have this type of situation with us, we don't actually have this kind of hierarchy with us, in these kind of situations, I really cannot use label encoders. Okay. I think so this label encoder could have been used on this size column. Maybe that would have made sense. So why not just simply change this part to size? And if I rerun all of this, you will be able to see that now if I do this particular thing, size column is something which is converted into 2, 0, and 1. Again, the same situation. Again, can you see that now the situation is that I'm able to go for medium as 1, large as 0, and small as 2. Now again, I don't think so the exact encoder knows that small is going to be, should be, or at least having the value 0, medium as 1, and large as 2. But we can set that automatically. We can map that also, but you get the idea. But what I'm trying to make you understand is that whenever we have this hierarchical situation with us, I guess label encoder is the best option to go for, and it makes sense as well, right? Again, but what to do if we don't have any hierarchy? For that particular thing, I have another type of encoding, which is basically my Scikit-Learn dot from preprocessing. I'm going to be again importing this particular part, which is one hot encoder. This is where I really like this particular encoder because, again, I don't know why some things fascinate you, don't they? Again, what I'll do is I'm going to be creating a df file, okay, which is going to be again a copy of this encoder, and here I'm going to be creating one hot encoder as 1, and I'm going to be saying that one hot encoder is going to be just called like a function which we have in this case. Then following the same process, why not go for df5? I'm going to be applying on the column called color, and in this case, using this one, I'm going to be saying fit and transform this color column. And once I do this part, I think I have this thing with me. df5 is there. Sorry. Sparse array should be with length. Let me just look into that part. This is correct, this is correct, this is correct. Okay. Sparse output I should set as false, maybe. This is what I was missing. Yeah. So if I go for df5 and after that, if I set this to color, you will be able to see that now it is converted something into 0, 0, and 1 and 0. That is what we have done so far, right? That is what I have done in this particular situation. So what this does is that I can set like, I can just really set this particular thing. Like I can take some values, like let's just say if I had a situation with me that was saying that the color was red, like if for red, my color was red. So naturally, do you think, like just to make you understand, don't you think so? Sorry. If my color was red, by the Boolean logic, I can set the value of red as 1, right? And since both of these values are absent, I can just simply label them as 0. I hope so you get that part. Like if the color is red, I can just simply set it to 1 and the rest of them can be 0. So for that particular reason, if I do this directly on a column like this, don't you think so that this is going to be a problem? Right, I think so that this is going to be a problem. Why is that so? Because right now, if I just do this on the column, which I was doing previously, the problem would be that I am not able to signify, or you can say, like able to get that what is this 0 representing, because to make this, like if this was a color or so, I need to be setting these values as together. That means there should be for red also, there should be for green and blue also. Okay. So that means if I wanted to convert any kind of column which I have using this one hot encoder, then all the unique values which I have for color would be converted into that same number of columns which I'm trying to tell you. Meaning, can I show you this particular thing? That means let's just say that if I was to choose, this particular part, that means if I was to choose this one hot encoder, what this will do is it will convert, let's just say for 1,000 columns, it is going to be needing 1,000 more columns so that it is able to signify that what type of data is going to be converted into what type, because it makes sense together only. So this kind of problem which I've run into is basically called as curse of dimensionality. Now, this term is used for models usually, but this dimensionality problem is basically caused whenever we have a lot more values than this 3, because in colors we have just 3 values. But if you assume that if in our situation, our dimensionality was, let's just say that we had, let's just say 100 unique values. So by this logic which I just showed you, don't you think so that it will also create what? It will also create 100 new columns. I hope so you get that. Why is that so? Because if for 100 unique values which I had, I need to set all of them as zeros or ones or zeros or anything like that. So it will be converting that into new columns, which is going to be having headings such as, in this case, we have red, green, and blue. So if I try to show you this, if I just try to show you this particular part very quickly, let me just delete all of this. And after that, if I choose this thing, such as if I just copy paste this part and change the variable names if needed, can you see that now once I'm done with this, you will be able to see that for color blue I have 0, color green, for that I have 0. But since in that particular case my color was red, it is converted to 1. Now for 3 unique values, I have how many values columns created? 3. So whenever there will be a lot more values, my problem is going to be a lot bigger, or you can say the number of columns are going to increase. And generally, there is a sweet spot in that. I don't think so that if my columns are going to be, let's just say 1,000, it is not necessary that the model which I have is able to, learn better. This is not the case. This is wrong. This is what people generally think, but this is not the situation. For more number of columns, it is not given that the model is going to be learning better. It is like a sweet spot. That means if my columns are, let's just say, only 2, then of course my model is not able to learn some patterns. It is going to be a weak model. It's not able to capture certain complex patterns that it should be. But if I have even these many number of columns, then I'm going to be having a problem. So in between these particular situations, I have to choose a number, which I'll tell you how. That is going to be my sweet spot. That is what we actually have to find out. And how do we find that out? That depends upon from data to data. Check. So with that said, I hope so that you were able to understand these kind of situations which I had, like how do you clean your data, what type of data is actually there that will determine the process of how do you clean it, and whatever situations which we have actually run into. I deliberately made some errors, I did something, I tried to show you some things, and for saving time as well, I guess I was able to show you each and every encoding, decoding, scaling, as well as standardizations and everything. Okay. So if you guys want these type of notes like this, which I'm using for this particular presentations, you can just leave a comment in the chat box, right? And I'll be happy to show you, or you can say share a link with you. And I guess with this, we come to an end of this session. So thank you for listening to me, and I hope I'll see you in the next one. So till then, just keep learning, keep revising, and I'll see you guys in the next one. Bye-bye.